Let me ask something, guys. Do you practice a little bit with the GeoGebra or no? You create account and GeoGebra because today we continue working with the GeoGebra. GeoGebra. You create yes or no? Using the chat.
I have an account, but I haven't practiced yet.
Well, no account?
No, I have an account.
Well, okay. Well, no, account is useful because you can save your work. So when you finish, you save.
Okay.
Okay.
Thank you.
Guys, I have good news for you. If you subscribe, hello, how you doing? Giovanni?
Chris, how you doing today?
Fine.
Everything?
I say something. If you subscribe in my YouTube channel, I give you 5 points in the test 4, in the test 3, and the test 4. Extra 5 points if you subscribe in my channel. When you subscribe, I can see the notification, no? If I don't see your name in the notification, I copy in one piece of paper. See, I don't see the notification, well, no 5 points extra. Okay? Okay. Question now. You see the board or no? You see the board. Okay.
Yeah.
Okay, you see the board. Okay. And today we cover operation with the matrix because do you remember the last time we working with the matrix, no? But we continue, but another approach, another different way, another point of view of the operation. So we're discussing operation with the matrix. Arithmetic operation, addition, subtraction, multiplication, division, the property. No, division no. Another operation is similar to division, but no, it's not division. Okay, let me record something. Remember, for example, if you have this matrix, 1, 2, 3. This matrix, que is only one column, have 3 rows and 1 column. Okay, and normally this matrix, que is like that, is called column vector. Es vector when at least one dimension is 1. It's vector. Likewise, we have, for example, 1, 2, 3, but in that direction. This is 1 by 3 because we have 1 row, 3 columns, and this is the column. Row vector. Row vector. 1 row. Wow. 3. 1 by 3 is row vector. Okay. Let's go move on to addition to matrix. It's super easy to understand. Super easy. We're doing behind, and just in case we practice 1 by 1 example today using GeoGebra. So I suppose that everyone open simultaneously Skype and GeoGebra, no? And switch into the, okay. Suppose the matrix A is just example. 3, -7, 0, 1, 2, 3. By the way, this dimension of the matrix 2 by 3, 2 row, 3 column. And the matrix B is given by -2, 8, 3, 2. Okay, it's exactly the same, 2 by 3. I want to perform the operation A plus B. Okay, A plus B is super easy because also to perform A plus B, we need to have the same dimension. If the dimension is the same, you can do that. If the dimension is different, no, we can. And you adding, this is 8, you adding 1 by 1, 3 plus 5, 8. -7, -2, -9. 0 plus 8, 8. 1 plus 3, 4. 2 plus 2, 4. It's a coincidence. And 3 plus 1 is 4 again. And this new answer is again 2 by 3. Exactly the same of the original. But you're adding entry by entry, element by element, in the same position. Any question? Easy, eh? This is addition. This is addition. Super easy.
Super easy.
Subtraction, exactly the same. Subtraction is you copy A, subtracting B. B es de menos M. I suppose que es negative, ¿no? Entonces 3 minus 5 es negative 2. Minus 7 and minus 2. A minus. Be careful with the sign. O sea, es minus 7 minus 2. Entonces doble minus. O sea, you change, es opposite sign. Entonces es negative 5. Okay, 0 minus 8 and minus 8. 1 minus 3 is negative 2. 2 minus 2 is 0. 3 minus 1 is 2. Again, 2 by 3. This is subtraction. Any question? Any question? Addition and subtracting matrices. Maybe you, in your moment, you understand what the reason I need to addition or subtracting matrix. Okay, let's see example to illustrate the application for this. Let me try to study some property regarding this idea of the addition matrix addition. The first one property is the commutative property. Okay, you see one, wow, professor, this is straightforward. Okay, this is clear. Of course, commutative. So you can interchange the element inside the operation and the answer doesn't change. Commutative. No, it's not elementary. It's not elementary because A and B is not the classical number that we are performing arithmetic. No, it's a matrix and it's a mathematical object. It has dimension 2 by 3, 3 by 3. But in this case, yes, it's commutative. We can interchange the element in the addition, of course, the subtraction never. And the answer stays the same. Surprise. When we study multiplication, you see that no, it's possible. Multiply in different order. Multiplication, no. Addition, yes. Associative property is when you have 3 elements, A, B, C. You can associate, for example, in this order. I open the parenthesis because you perform first B plus C, and after the answer for B plus C, adding with A. Another student says, no, I don't like this way. I am doing it this way, for example. You perform A plus B first, plus C. This is associative property. It's valid in addition. You can use it either order, the order that you want, associated in addition. Number 3 is, for example, when you subtracting A minus A, wow, you subtract the one matrix minus itself, the answer is 0 matrix. But 0 matrix is not 0, it's the matrix, any element is 0. Suppose 0, 0, 0, 0, 0, 0. Suppose we are talking about the 2 by 3 matrix, no? 3 by 3, we have 9, 0. This is a 0 or null matrix. Null matrix. So you're subtracting, you get the null matrix. And the last property, que es elementary, is si you, for example, addition, the null matrix is equal the same. Okay, and this look like similar to the numbers. But I repeat, guys, not always it's the same with the numbers. So don't using your common sense of the arithmetic because matrix is a complicated mathematical object that contains one dimension and no, it's not 1 by 1. It's 2 by 3 or 3 by 3 or 4 by 4 or 25 by 25. Okay, let's go to the multiplication. But okay, no. Wait a second. Let me let me move on, sorry, to the GeoGebra. I want to open GeoGebra now to illustrate very well addition and subtracting using GeoGebra. No, it's a confirmation that we are doing well. No, okay, GeoGebra now. Look, okay, look at that. I'm switching to GeoGebra. Okay, look at that, GeoGebra. You see GeoGebra?
Yes, sir. We see it.
Excellent. Entonces I typing before the start of the class the matrix here and the spreadsheet 3 negative 7 0 1 2 3. You create a matrix. I explained the last time. No? I want to using a different idea. You click on the object and one. You say I change the name, rename. I want to call matrix 8, capital A. Exactly, we are using our paper. No? Likewise, I highlight this, create matrix. Entonces I want to use this new idea, no? Rename. You can rename, delete. This is matrix B. Normally, the name of the matrix is capital letter. Entonces, in the cast, you put A plus B. A plus B. Sorry. A plus B. And boom. And this is the answer. Exactly the same we are doing by hand in the paper. A negative 9, A 4, 4, 4. And now A minus B. A minus B. Enter. Negative 2, negative 5, negative 8, negative 2, 0, 2. Super. Any question? I repeat the idea in the test number 3, the majority of the operations we are doing with the matrix, and there are some specific questions that you need to do by hand. You show me a word by hand, but the majority is using the software. Okay, super. Let's move on to the whiteboard again. Okay. Okay, here you go. I want to erase the whiteboard because I want to explain multiplication. But first of all, I want to explain multiplication by a scalar. It's a scalar multiplication. Multiplication. What is the idea for a scalar? A scalar is no matrix. A scalar is the number that frequently we are working, 5, 20, negative 5, negative 10. A scalar is just a number, no dimension. But for example, let's do in the operation 5 times 8. And remember, A was the original example, no? Is 3, 7, 0, 1, 2, 3. Okay, we're using the same example because I don't want to edit more. So say you multiply by 5. When you multiply by 5, any element inside the matrix is multiplied by 5. So say 15. This is negative 7, sorry. Minus 35. 0, 5, 10, 15. Multiplication by scalar. It's multiplication of any element. So in the matrix operation, when you are doing one operation outside, this operation is transmitted directly to any element inside the matrix. We study, not today, another thing is similar to the matrix, but it's no matrix, it's completely different multiplication. Okay, suppose we have B. Remember the famous B, we were working in the addition problem, no? 5 minus 2, 8, 3, 2. I want to perform 3B. What means 3B? 3 is a scalar. Multiplication by the entire matrix B. Give me 3 times 5, 15. 3 times negative 2 is negative 6. 3 times 24. 3 times 8 is 24. 3 times 3 times 3 is 9. 3 times 2 is 6. And 3 times 1 is 3. Okay? And this is multiplication, another example of the multiplication of the by scalar. Scalar is just a number. And when you put a number outside the matrix, multiply any element by this. Suppose in the test I ask you, compute 5A plus 3B. Well, so in this case, we have 2 multiplication by scalar that we did before. And finally, to complete the final answer, I adding this matrix plus this matrix. So say 15 plus 15, 30. Negative 35 minus 6 is negative 41. 0 plus 24 is 24. Okay. Super easy. 5 plus 9 is 14. Okay, this 5. 16. This 10 and this 6 and 3 is 18. No? 18. End the story. In this case, we are doing operation, multiplication by the scalar, and also addition. And you write this algebraic expression using matrices. So 5 is a scalar, 3 is a scalar, but A and B no. A and B are a matrix. And by the way, the matrix have the same dimension. So you put different dimension and you try to put in GeoGebra and you try to add in 2 different matrices with different dimension. GeoGebra say, no, mismatching dimension. This is impossible, student, because I adding or subtracting matrix with the same dimension. Okay, by the way, in this case, 3 by 2. Okay. Okay, let's see quickly one elementary. Well, everyone follow me? Question? Question. It's okay?
So far,
No
so
question?
good.
Okay, good. And the rest of the student guys? Sound good? Okay. No complaint. No complaint. Okay. Do you see the board again? Okay. Suppose application of this. Everyone application. Suppose A is 2, 5. 1, negative 4. This is given. The matrix B is also given. 6, negative 1. Negative 1, negative 3, and negative 8. Entonces, I ask you, for example, in one equation, 4x minus A equal B. Wow, what the hell is that? It's equation. It's equation. It's equation in matrix. 4. So A is this matrix, no? B is this matrix. Now what about X? Capital X. Capital X is a matrix. Capital X. Capital X. Is the matrix is formed, for example, for the one vector is little x, little y. No, little x, little y. This is mistake. This is the, okay. The dimension for this is wrong. This is wrong. Let me see how many elements we have. Look, the dimension for this matrix is 2 by 2. 2 row, 2 column. The dimension of this is 2 by 2. This is 2 by 2. This is 2 by 2. I suppose que 4 is a scalar. Entonces, x is 2 by 2. Entonces, I don't know. I have no idea. A, B, C, and D. Que es 2 by 2 also, right? And you have to solve for x. In other words, I need to find the value A, B, C, and D. Okay? So we are doing exactly the same or similar to the elementary algebra. You bring A to the other side, addition. 4 capital X is equal A plus B. This is a new matrix, A plus B, is 2 by 2 also, no? Like that. And finally, 4 is a scalar. You divide by 4. You divide by 4, division by 4, so X alone is my isolated. X is 1 over 4, it's a scalar, A plus B. Okay? Let's do it step by step. A plus B. A plus B is addition, A and B. A plus B is 8. Where I come from this 8? 2 plus 6. 5 minus 1, 4. 1 minus 3 is negative 2. Negative 4 and negative 8 together is minus 12. This is A plus B. Finally, X matrix is 1 over 4, A plus B. In other words, you divide by 4 any element. A divided by 4, 4 divided by 4, minus 2 divided by 4, and minus 12 divided by 4, no? When you reduce in the lowest term, it's 2, 1, negative 1/2, and negative 3. End the story. And this is my answer. My answer is the matrix X I'm looking for is this matrix. Okay, of course, how we predict the dimension is 2 by 2. Okay, so this is the idea today. The idea today is operation with the matrix. Entonces we're using this fantastic idea for solving linear system of equations in one unbelievable and fantastic way. Remember, we studied last time reduced echelon form. Is it good? I like that. But this is a new one that we studied today. Okay, so if everyone understands this is a motivation example, no? It's a matrix equation and matrix form. Let's explain in detail now. Wow, multiplication of the matrix. I bring 3 examples. And let's try to do at least, I don't know, by hand and GeoGebra, because it's long process. So multiplication for the matrix. Pay attention, guys, because this is complicated. Not super, but it's complicated. Now, title is multiply or matrix multiplication. Multiplication. Okay, in this case, we multiply 2 matrices. No scalar anymore. No. Suppose I call C matrix. Okay, the matrix 2 minus 3, 1, negative 4, 7, 0. And the matrix D, okay, the matrix formed by negative 1, negative 6, 10, 5, 8, negative 2. Okay, the first thing you should do is analyze the dimension. The dimension for the first matrix is 2 by 3. 2 row, 3 column. Perfect. The second matrix is D is 3 row and 2 column. I want to do the multiplication C times D. Okay, the first thing you should do is analyze the dimension. Let's see if the dimension matching or no. The first row, the first matrix is 2 by 3. The second is 3 by 2. This number must be the same. It's 3 in this case. In other words, the number of columns of the first matrix, 1, 2, 3, matching perfectly with the number of rows of the second, 1, 2, 3. And the result, I want to call E. No, CD. Oh, you know, another example, C. Let me call CD. The answer is represent a new matrix, and the dimension is 2 by 2. Wow, professor, why 2 by 2? Because the remaining number, look, is 2. This 2 is this 2. And this 2 is this 2. In conclusion, guys, to multiply two matrix, we need a matching perfect in this number. We see an example in which don't matching this number. If you don't match it, we cannot do multiplication. That's it. And you would know it's not applicable, the multiplication, because don't match the dimension. After that, you analyze the dimension in the other side, this dimension, look. And this dimension is this dimension. Now, when you multiply C and D together, we get a short, a new matrix is only 2 by 2. Let me explain the rule. There are different rules. There are different, I want to explain different rules to perform multiplication of the matrix. Suppose I want to copy again the matrix 2, -3, 1, -4, 7, 0, time, -1, -6, 10, 5, 8, -2. Okay, yeah, I suppose okay, when you get the answer, we have another matrix. Let me copy the dimension again. 2 by 3, 3 by 2, matching perfect, and the answer is 2 by 2. And this is, let me call CD, CD11, because of the element of the CD located in the position row 1, column 1, CD12 is the element located in the position row 1, column 2, CD21, CD21, row 2, column 1, and CD22, because it's the element located in the row 2, column 2, no? Entonces, what is the idea? What is the formula? What is the formula to perform the multiplication? When you multiply this matrix, times this matrix, for example, you get that value, you multiply row 1, the entire row 1 of the first matrix, C, multiply by the entire column 1 of the second. So this one indicates row 1 in the first, and this one indicates the column 1 of the second matrix. So it's basically C11 or CD11. CD11 is 2 times -1 is -2. -3 times 10 is -30. And 1 times 8 is positive. So the answer is -24. Okay. No bad. Then I copy here. I copy the same matrix, but instead of CD, I put -24. That's the answer. Okay, CD 1, 2 is the multiplication again. The row 1 of the matrix C multiplication by the entire column 2 of the second matrix, or the D matrix. Remember, this is C and this is D. So you multiply 2 times -6 is -12. You multiply -3 and 5 is -15. 1 times -2 is -2. And the answer is -29. I copy here, -29. Okay. And now let's move on to the CD21. CD21 is the multiplication now. The row 2 of the matrix C multiplication again by the column 1. So 2, 1. Row 2 in the first, column 1 in the second. You multiply 4, negative 4, sorry, times negative 1 is positive 4. 7 times 10, 7. 0 times something is 0. The answer is 74. And 74 here. And finally, 2, CD 2, CD 2 is again the row 2, this one, of the C multiplied by the column 2 of D. Entonces es negative 4, negative 6 is 24. Plus something 35. 7 times 5, 35. 0 times negative 2 is 0. Okay. And this is 59. And the answer is 59. Okay, 2 by 2 matrix, 59, 2 by 2. And this is the answer after the multiplication, C times D. This is one way to do. Another way to do, I did element by element. CD11, CD12, CD21, or CD21. We can do it another way. Yes, we can do it another way. We can do in another way. Let me show you another way to perform the multiplication, and you make a decision what way you prefer. Well, I prefer GeoGebra, no? But okay. Suppose I copy again the matrix C, exactly the same. Negative 4, 7, 0. Entonces, don't multiply by the entire. No. I do partitions. I take only the first column of the matrix D. Look at the matrix D, the first column is negative 1, 10, and 8. Just in case, before to start, let me check it just in case the dimension. The dimension of this guy is 2 by 3. The dimension of this guy is 3 by 1. The dimension matching perfectly. And the answer that we expect is 2 by 1. So we expect 2 by 1, que is 2 number. Okay, suppose, using my imagination, okay, CD11 and CD21. Okay, this column. And the operation is similar. It's exactly the same thing we are doing before. Look, the operation is negative 2, negative 30, and positive 8, negative 20. Negative 4 is positive 4, 70 and 0 is 74. And we get exactly the same, this piece of the answer. And likewise, let's do it here. I copy now 2 minus 3, 1, negative 4, 7, 0. Multiplication by the second column, no? The second column is negative 6, 5, and negative 2. The dimension matching perfectly because it's 2 by 3, the 3 by 1, perfect. We expect 2 by 1, que is just vector column of dimension 2. It should be CD 1, 2, and CD 2, 2. When you are doing this operation, is negative 12, negative 15, and negative 2, exactly like that. Entonces, minus 29. And the other is negative 4, que is 24, 35, and 0. The answer is 59. It's exactly the same, this idea. And we can do partition, not necessarily doing element by element. Okay, we're doing partition. It's the only possibility. No, there are a lot of possibilities. No infinity, but we have, we are doing another kind of operation. The most common is element by element or by column, like I suggest. So you separate the entire matrix C, que is the first one, and different column of the second matrix. Just in case, let's do it in GeoGebra and checking. Checking, guys. I switch into GeoGebra. Okay. Switch into GeoGebra. Oh, no, it's not available. GeoGebra, okay, there you go. Checking. Cancel. Switching. Okay, GeoGebra, perfect. Switching window. Okay, there you go. And remember, in the example, we have two matrices. The first one is 2, 3, -3, sorry. -3, 1, -4, -4, and the other row, -4, 7, and 0. This is my matrix C. My matrix D is -1, is -6. Okay, very important. Be careful when you typing, when you edit the matrix, because you change the number, you change the sign. We are doing totally different problem, and we don't expect the answer we need. 8 and -2. Okay, copyright, no? I select the first matrix, create matrix. Boom, and I change the name. This matrix C, capital C. Now, likewise, create. Wow, what the hell? A ver, let me see. Okay, select, right click, create matrix. Okay, boom, I change the name, edit. Matrix D, capital D. Entonces, in the cast block, I put C tiny. C multiplication is, you know, the classic after is shift 8, or in the numerical block in your computer, you put multiplication time. Boom, press enter. Boom, pataboom, patapam. The answer is -24, -29, 74, and 59. Any question? I promise after that, we are doing one couple more of the exam, of the multiplication for them. Any question? Any question? Any question? No. Everything okay?
Yeah.
Come on.
Looks good for now.
Okay. Let me show you now another interesting example. Let's do it by hand, and after we check it with the Desmos. Desmos, no, algebra. I say Desmos. Okay, switching to the board, whiteboard now. Whiteboard now. Okay. Whiteboard. Okay, whiteboard. I erase the whiteboard. I erase the entire canvas. Boom. Okay, let's do in this example I bring for you. It's easy, but it's interesting to understand. Suppose I need to multiply this matrix I want to call A. No A, another name. Let me try to call E and F. No, it's the same, no? Entonces it's confusing the name in the GeoGebra, no? Suppose E is a matrix formed by 3, 5. 1, 2. And F is another matrix is 1, 2, 3, 4. Okay, they want to perform this operation. E times F. 2 by 2. 2 by 2. Oh, perfect. Matching the dimension perfect. These two is the same. These two. And the new matrix form is 2 by 2 also, right? We expect 2 by 2. 2 by 2. 2 by 2. And the answer that we expect is 2 by 2. We have 1, 2, 3, and 4 elements. Let's compute it one by one. Is you multiply, remember, this times this. Entonces, 3 plus 15. 3 times 1 is 3. 5 times 3, 15. And 3 plus 15, 18. Okay. To find the second element here is multiplication, again, the first row multiplication by the second. I'm using another color. Entonces, 3 times 2, que es 6, plus 5 times 4, que es 20, and 20 plus 6 is 26. Okay. Now, in order to find the next guy here, you multiply the second row multiplied by the first column. Because this element is the element que lie in the position 1, 2. No, 2, 1, sorry, 2, 1. The 2, 1. Entonces, 1 times 1 is 1, plus 2 times 3 is 6, 6 plus 1 is 7. Finally, 2, 2 is 2, 2, so row 2 and column 2. Entonces, 1 times 2 is 2, and 2 plus 4 is 8, 8 plus 2 is 10. And this matrix is 2 by 2. Now, surprise. Look at that. Suppose I perform a multiplication in different order. I suppose I want to do the operation F times E. Okay, you multiply F times E. You say switching the order. Switching the order is, okay, let me try to, okay, is, you copy F first. Okay, I suppose that the dimension matching perfectly because 2 by 2 is a square. Now, but I copy F first. 1, 2, 3, 4. This is this, F. And E in the second place, 3, 5, 1, 2. Entonces, the order of the multiplication is the same, no? When you multiply the first and the first. The 1 times 3 is 3, and 2 times 1 is 2, and 3 plus 2 is 5. You see a different answer? Let's continue. Multiplication by the second one. 1 times 5 is 5, 2 times 2 is 4, 5 plus 4 is 9. The second element, 3 times 3 is 9, plus 4, 13. And the last element is 15. 3 times 5, 15. 15 plus 8 equals 4 times 2 is 8, 22. Conclusion, guys. Conclusion. In general, this is a contra example. Que prove somehow that the multiplication of the matrix is not commutative. But you have two matrices, E times F is not equal F times E. Okay? And this is weird, but it's the situation. It's not commutative. And the reason is because the matrix is not just a number, the regular number that you are working all your life, no? This is an object, and after matching the dimension, but the order is super important. Therefore, when you are doing in the algebra of the matrix, if we are doing now, in a few seconds, a few minutes, when you are doing the multiplication, suppose that I have one matrix, A. And you multiply by B. This operation is called post multiply. Y plus is like after. So you have the original matrix, you multiply by A, B in this direction is post multiply. Suppose we have the A matrix and you multiply here. It's different. It's pre-multiply. Pre-multiply. Okay, so be careful because you need to be aware. So you post-multiply or you pre-multiply. It's totally different because you know that the multiplication of the matrix is not commutative. It's not commutative. So this is the time, well, not necessarily the time, but well, it's the time to summarize the property, the most important property for the multiplication for the matrix. So I try to condensing the information that we have so far of the property. So what property is good, what property is not good, what property is true, what property is not true. Okay, property of matrix multiplication, property of matrix multiplication. Okay, the first one is the associative. The associative is good. A, B, C. A, B, C. You, for example, multiply this guy first or multiply this. Either way. Associative is good. Second, commutative is not good. A times B is not equal B times A. Guys, in general, I want to study after that a particular example in which is true, a multiplication. But this is very, very weird and very, very specific in one condition. Number 3 is distribute the property. Distribute the classical distributive property that you apply in algebra. We can apply use a matrix. To multiply this guy times this guy times this guy is A times B. Time, this is time, of course. Okay, this is not the classical multiplication by scalar. No, it's multiplication between matrices. Plus the A times C. This is distributive property. Okay, one more example before explain another idea. Suppose one stupid example. I put a stupid example in the test also. Look, this example is stupid. 2 minus 8, 1, 6, 0, 1. Multiplication by another matrix is minus 3, 2, 1, -1, 6, and 1. Okay, suppose in the test you can see something like that. You analyze the dimension first. This is 3 by 2. This is exactly the same, 3 by 2, nice. But the dimension doesn't match. Then what is the idea? Not defined. Multiplication. It's impossible. Not defined. Not applicable. The multiplication. And you try and algebra, you think it's wrong. Okay? Okay. So now we have division of the matrix, no? Unfortunately, we have no division, but we have another case similar to division, que es the inverse matrix. I want to explain the inverse matrix right now. Inverse matrix. Inverse matrix. The inverse matrix, the notation that we are using, suppose that the matrix, the original matrix is A. And suppose example, I want to explain, use example. 3, 5, 1, 2. Yeah, I want to find the inverse. It's inverse. Inverse, the notation is something like that. Bam! Inverse matrix. I want to find this inverse. What is the idea? This is a symbolic way to indicate inverse, and this do not indicate exponent. So this -1 is no exponent. It's not equal. It's completely wrong. 1 over A. Okay, no, this is wrong. This is just inverse matrix. So what is the property for the inverse matrix? I want to explain it. When you multiply the original matrix times the inverse matrix, okay, and in this case, pre-multiply. The answer is identity. Wow. But what dimension? One. Okay. The identity matrix is only defined by the square matrix. 2 by 2, 3 by 3, 4 by 4, 5 by 5. When the rectangular matrix, no. It's impossible to find inverse matrix. It's possible, but it's a more complicated. You take linear algebra classes. You determine inverse matrix and rectangular, but this is no inverse matrix. And is no inverse, it's pseudo inverse. But forget about it. In college algebra, inverse matrix, and pre-calculus, inverse matrix. It must be square. The dimension is the same. Okay, so when you multiply any matrix, this matrix, with the inverse I want to find right now, you get identity matrix of the dimension 2, okay? Because it's 2 by 2, so it's 3 by 3, yes, 3 by 3 dimension. And you remember that identity matrix is 1, 0, 0, 1. 2 by 2. So it's identity matrix of dimension 2, the symbolic is right like a capital I, 2. This is valid, si it's 3 dimension, the matrix original, you multiply by its inverse, and the answer is identity matrix dimension 3. Okay? Okay, so what is the, let me try to explain, wow. 2 different ways, or 3 different ways to find the inverse matrix. I want to start for the intuition. After I want to explain the shortcut. And also I want to generalize to the any dimension, 3 by 3, 4 by 4. Okay. Suppose this example. In this example, in order to find the inverse matrix, my goal is to compute the inverse matrix. This question one. You create one augmented matrix formed by A. And you put a line in between here, and you put the identity matrix here. Now this is the original matrix is given. This is the identity matrix of the same dimension. No? And now you perform reduce row echelon form. Exactly the same we are doing in the last class. Okay? And surprise, we are doing here, when you finish that, we are doing this using GeoGebra to save time. The answer is 1, 0, 0, 1 line. In the right hand side we have 2, -5, -1, and 3. So this again, when you perform reduce row echelon form, this is the identity matrix. Again, this is exactly the same of this. Look, this and this is the same. This and this is the same. But this is A and this is A inverse. Wow, amazing. Okay, we can do by hand, of course, but no, don't waste time by hand. Okay, look. But I want to check it, but I check it by hand. Suppose definition was this. You, for example, post multiply the original matrix is A 3, 5, 1, 2. Multiply by this, the hypothetical, I suppose it's true, because it's inverse. 2, -5, -1, 3. And let's see what happened. 2 by 2, 2 by 2, I get the answer 2 by 2. And you multiply 3 times 2 is 6 plus 5 times -1, que es -5, es 1. 3 times -5 is -15 plus 5 times 3 is +15, 0. 2 or 1 times 2 is 2, -2 is 0. And -1 is -1, no, sorry, +1 times -5 is -5 plus 2 times 3 is 6 is 1. Boom. Identity matrix, dimension 2, inverse matrix, and original given matrix. This is like I did the pre-multiplication, or no, post-multiplication. Post-multiplication of this. And let's see I pre-multiplication. So I switch the order. Suppose I copy 2, -5, -1, 3 times the original matrix is 3, 5, 1, and 2. Let's see what happened. I don't know. I'm using green color. Is 2 times 3 is 6, minus 5 is 1. 10 minus 10 is 0. Negative 3 positive 3 is 0. 15. No, it's 2 is 5 and 6 is 1. Wow. Again, so and this is a special multiplication. When you multiply, this is always happen. When you multiply A times A inverse or A inverse times A, the answer is identity. And the identity matrix, in my opinion, is a special, super special matrix because when you multiply any matrix, any matrix, so you multiply any matrix, A, times identity matrix, this identity matrix work like a big one of the multi-dimension. The answer is A. Suppose get 2 by 2, this is 2 by 2, and this is 2 by 2. That this answer is exactly the same as the answer. When you multiply by the identity matrix, boom, 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 the answer doesn't change. Okay. Okay. This is, I am doing, okay, pero, okay. Listen to me. Let's go to the GeoGebra to verification that the thing we are doing is correct or incorrect. Okay, let me switch into GeoGebra. Switch it to GeoGebra. Boom. I got it. Switch the window. Okay, wait, GeoGebra, where is this? Suppose case here, over there. So I copy the original matrix is 3. I want to. This is the original. Okay, why not? Entonces no, I want to copy the augmented matrix, que is formed by the original matrix and identity matrix together. 1, 0, 0, and 1. Okay. Yeah, I formed this big matrix, que by the way, the dimension is 2 by 4. Okay. Create matrix. I don't care the name. The name is not important. And matrix 1. I type in similar to the another class. I type in reduce row. Remember, capital R reduce. D reduce for echelon form. I got that. Inside I put M1. M1. Present. Boom, bada boom, bada bang. Look at that. What happened in the left part we have the identity matrix. In the right part we have the inverse matrix. Let me verification. Okay, let me verification. I want to copy again. 3, 5, 1, 2. I discover in using this way okay, the inverse is 2, -5, -5, -1, -1, +3. Okay, +3. Okay, entonces I call this guy. I need to put a name. Well, M1, M2, M3. We create the matrix. Let me see. Create. No. Create matrix. Okay. Remember, this is M2. And inverse, I suppose, M3. No? M3. And let's do the multiplication. Let's do the multiplication M1 times M2. Boom. No, N2, no, sorry. N3. N2, and low, N2, N3. Question mark because it doesn't match in the dimension. Boom. Do you see identity matrix? And let's do it in opposite order. N3 times N2. Enter again. Boom. Identity matrix. Super. Okay, another way. We have three different ways. We start this way, good. Using the echelon. No, okay. It's the most common. The most common is that way I want to explain. I go back to Okay. The whiteboard. Switch whiteboard. Okay, whiteboard is missing. Wow, carajo. Okay. Whiteboard now. Switching. Good. Okay. Okay. Do you see the whiteboard? Okay. Do you see that? The whiteboard? Okay. We continue in this example, but another approach. Look at that. Let me try to discover the formula. The formula to find the inverse matrix. Suppose que the matrix A in general, matrix capital A, is AB, CD. Call a letter, but a different number. Therefore, the inverse matrix associated with this is inverse. Is equal. Okay. Entonces, the formula is, wait. The formula is D minus B minus C and A divided by 1 over AD minus BC. Look like complicated? No, it's not complicated. Look. Okay, you computed this scalar first. You computed this scalar. This is just a number, okay, scalar. And this scalar is multiplication AD. And our specific example, remember, is this example, look, A is 3 times 2. So you multiply this number and this number. And multiply this number and this number. But this is plus and this is minus, no? 8 times D is 6. And 1 times 5 is 6 minus 5, 1. So this is scalar. And this example, I select easy. You understand? F1. And 1 is invisible, multiply. Let's stay D. Okay, D is 2. D is 2. Look, he is this guy. The last one, D is 2. Minus B. And B is 5. Minus 5. Negative 1 is negative 1, no. Is negative C. Is negative C. C is 1. Negative 1. And A is 3. Wow. Look, we get the same answer of this. Without don't do echelon, no. Using the formula. Guys, this formula is only valid by 2 by 2. Si es 3 by 3, we have no formula. Well, actually, we have formula, but it's super complicated. And nobody using this formula. 2 by 2, yes, you can do by hand. Okay, another way is using this operation. Let me show you in your GeoGebra one more time. Look, the three different approaches to get the inverse matrix. And you see, well, professor, but what is important? I need to understand what is important in inverse. Okay, I want to explain now. Okay. Okay, there you go. Is it your GeoGebra, right? Okay, remember the original matrix was this one. Okay, I want to call M2, no? N2 is the original. This was N2. Look here. So you type in the cast, you type in invert, pero invert is weird. It's I invert. Invert. Something like that. Invert, no inverse. I don't know why. I don't create GeoGebra software. Invert. So you type in here invert. And you inside you put N2, N2. Present. Oh, look at that. What you get exactly the same answer. 2 negative 5, negative 1, 3. Super. Everyone understand very well this?
Yes, sir.
Okay. Now, the most important moment. The most important moment is the last moment. Always happen this situation. And in the movie, the most important no necessarily is the last. No? Okay, so what is the idea for the application of the inverse matrix for solving system of equations? for solving system of linear equation. Look. Let me show you the theoretical part, and after that, I want to do at least one example. Maybe next time I will do another example, and that's it. I go to the whiteboard. Okay, whiteboard. Erase the canvas. Okay, inverse symmetry help me to solve a system of equation. How? Well. Suppose, all right, let me see one example, good example. Okay, this is a good example. This is good, I like this. Suppose the system of equation like that. 3x minus 2y.
You're still in
Sorry.
algebra. It's okay.
Sorry.
No problem.
Thank you for you helping me. Okay. Now everything is okay?
Yeah, we're good now. Thank you.
Plus C equal to equation 1. X plus 4y minus C equal 6. Equation 2. 2x plus 5y minus 2c equals 6. Again, what? It's a coincidence. Okay, this is my system. How you know solving this using reduced row echelon? But we solve it different. We will write this system a matrix form. How? Okay, you copy capital A matrix, que is formed by coefficients in front of the variable S3, minus 2, 1, 1, 4, negative 1, 2, 5, negative 2. Okay, and we have capital X. The capital X is the column vector that's formed by leader X, leader Y, leader Z. This X is this X, leader X, leader Y, leader Z. The capital X is formed by all the variables. This is 3 by 3 square, 3 equation, 3 column. The column for the X, the column for the Y, the column for the Z. And this is 3 by 1 because it's 3 equation again, but 1 column is the unknown column. No? Okay, we have only one, X, Y, Z. And when you perform the multiplication, look, matrix form. A times X is the dimension, let me check it just in case, is 3 by 3. This is 3 by 1. Oh, nice. Dimension is the same. And we expect one matrix is 3 by 1. Like this matrix is 3 by 1. Absolutely is this piece. I want to call B. B matrix is the matrix is the column, no? Vector, que es 266, que es the right hand side. Okay, entonces I immediately convert this system. I don't care. See, we have 25 equations and 25 unknown, and we have a condensing equation. This is the super fantastic advantage of the matrix. You have in the real life one object can have 25 dimensions, and you condense it in only one block because the matrix is multi-dimensional. What is the formula? What is the formula? Well, the formula is exactly the same we are doing by hand in elementary algebra. Suppose the equation 2x equals 4. You divide by 2 both sides, no? X equals 2. Done. In this case, you cannot divide by 8 because we have no the division of the matrix, but you have the inverse matrix. I suppose that this equation you pre-multiply by inverse matrix. Y when you multiply, you know, when you multiply the inverse matrix times any matrix, it's the same. The answer is identity matrix. And you know, identity matrix times any matrix is exactly the same matrix, capital X. And the formula is this. The conclusion, you set up matrix A, you find the inverse matrix of the matrix A, you set up the matrix B and multiply each other, and you get the vector que represent the solution, X, Y, and Z. Let's do in 5 minutes, no? Using, because the only problem, the disadvantage of this is there's too many arithmetic. However, when the software, you optimize this idea. Okay, so let's move on to the GeoGebra again one more time. Okay. There you go. Okay. Remember the formula, inverse matrix time B. So basically, I need to define new matrix. Get the matrix 3, -2, 3, -2, +1. The second row, 1, 4, -1. And the last row, 2, 5, -2. -2. Okay. This is my matrix. I don't know what name I want to call. Maybe R, capital R, whatever. Let me create the matrix. Create matrix. Boom. I want to change the name. Rename. I want to call capital R. Capital R. Okay. And the second matrix involved in the problem is the column vector 2, 6, 6, double 6. Let me create this matrix. Create matrix. I want to change the name. Well, I don't know what name. Let me put the name W. Any name, Maria. I can type in my name if you want. What name I say? W, no? W, capital W. Remember the matrix normally using capital W. Okay, so I need to find and the cars. I need to find the inverse of R multiplication by W, no? That's the solution, no? R, no? Invert is invert, remember? That way, invert. That's weird, invert. Ending in T. No, inverse. I don't know. Inverse of matrix. What matrix? R.
Invert is the verb.
Okay. Oh, this is inverse. Weird. But I don't like this guy. I like multiplication. I come back to the same operation. Yeah, I put multiplication by W, no? Yeah, I press enter. Boom. Look at what is the answer. The answer is 1, 2, 3. The answer is 1, 2, 3. So X is 1, Y is 2, and 3 is Z. 1, 2, 3 is the answer for this. When you multiply, okay, let me go to the whiteboard to understand this. Okay, the answer was, okay, this was the formula. But in my specific problem, in GeoGebra, because I have a lot of matrix, if you want you delete some matrix, I call R inverse. Like that. Time W, no? And the answer was a vector 1, 2, 3. And remember, who is capital X? Capital X is
You're still in the GeoGebra.
Oh, yo. Okay. 4. Okay. Okay. The thing I'm explaining is, in my problem in GeoGebra, I call no A inverse B. I call R inverse time W, no? And to say I get the answer 1, 2, 3. but capital X is this. Is X, Y, Z. Therefore, es obvio que X is 1. Look at that. Y is 2. Look at that. And Z is 3. This is another approach, guys, to compute a system of equations using algebra of matrix. In this case, was inverse matrix and multiplication. This is the fantastic formula. Okay, some people like so much this formula. Okay, so I promise the next time we study another way. I bring more examples of the inverse. Yeah, study another way more to, and you make a decision. Oh, no, that you don't make a decision. And the test I am forced to you to do by inverse matrix or do by echelon form.
Here's what on the test. This is how you want to see it, right, Professor?
Say again.
This is the way you want to see it on the test, correct?
The test, I programming in the syllable, no? It's your question, mister. Okay, listen to me. Listen to me. Okay, and the syllable. Okay, we have time. Don't worry. Be happy. We're on time. I have the syllable here just in case. Today is November 3rd. November 3rd is operation with the matrix. November 5th is this week, Thursday. Inverse matrix and matrix equation. We repetition a little bit, not too much. November 10th, determinant and Kramer rule. And November 12th and November 17th is review. And November 19th is the test. Well, I send the test. I send the test and you resend to me November 24th. So we have time. Okay, what do you say? Come on, I don't read. Activate the microphone. What do you say about the test? Do you understand very well? Don't worry.
No.
Don't worry for the test. Don't worry. In your time, I repeat the test. I send the review package. We are doing the review package here in front of you. Today is theoretical part. So the thing we studied today was operation with the matrix, addition, subtraction, multiplication, inverse matrix, and application and the solution for the system of equations. Okay?
I was just explaining to him what you said. That's it. Have a great day.
You too.
Have a great day.